Now we're going to look at graphing some more involved exponential functions. Okay, in order to do this, we're going to use the transformation properties. So if we take a look at this function here, we've got f of x equal 2 to the x minus 2 plus 3. Now, this minus 2 is inside of my exponent. That is going to shift my graph to the right 2 units. Well, misspelled it. But it's going to shift to the right 2 units. And this plus 3 will shift it right 2 units, up to 3 units. Okay, so all we have to do is graph f of x equal 2 to the x, and then shift our graph according to what the equation has. So 2 to the x, that gives us, first we have 1/4, 1/2, 1, 2, 4. So we'll dash this one. That is just 2 to the x. Now if I apply the minus 2, that's going to shift all of these points to the right 2 units. Okay, so this one goes 1, 2, 1, 2, 1, 2. So now my graph looks something like that. And then the final one, the plus 3, is going to shift all these points up 3 units. So 1, 2, 3, 1, 2, whoops, 1, 2, 3. That point's actually right here. Then this one is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the final graph is here. So in this case, my horizontal asymptote is at y equals 3. Okay? So it's pretty simple. Anything that is inside the exponent is a horizontal shift, the opposite of what it says. Anything outside the exponent is a vertical shift in the same direction. So let's take another example. Let's have f of x equals e, let's make it negative e to the x plus 1, then minus 2. Okay? So if we make a note, this negative in front of e is going to reflect across the x-axis. Then this plus 1 is going to shift it left 1, and then the minus 2 here is going to go down 2. So first I need to graph f of x equal e to the x. Now if you recall, e is the natural base of an exponent. So e is approximately 2.71828, so on. So if we plot the points based on that, e to the 0 is 1, e to the first is 2.718, so about right here. And then again we'll dash it. So there's e to the x. The negative exponent, the negative in the front is going to reflect across the x-axis. Oops. Right about there. that takes care of our negative. Then we have the -1. So everything's going to be shifted to the left 1 unit. Or the +1, I'm sorry. Shifts it to the left 1 unit. So now I have this. And then finally, the -2, which is going to take everything down 2. So 1, 2, 1, 2, 1, 2, 1, 2. And now, -2 is my horizontal asymptote. So, in general, first graph your base function, then use the changes in the equation to reflect or shift your graph in terms of what it does. Anything in the exponent is a horizontal shift, opposite of what it says. Anything outside of the exponent is a reflection across the x-axis.